Hey guys, a few months back I did a video during one of my projects where I received a box of parts, and I teased a little, asking if anybody could guess, based on the parts that I ordered, what an upcoming project might be. Well, this is it. So, the owner of that Admiral T2301 I finished recently also dropped off this set at the same time. If you go back and watch part 1 of that series, you would have gotten a little look at this. This is a classic late 40s GE Bakelite TV, affectionately known as the locomotive because of the streamlined shape of the cabinet. I used to own one of these, but I actually sold it. I do still have the wooden cased version of it though, but I have not gotten around to restoring that, so this will be my first time actually working on one of these, although I am fairly familiar both from looking at the chassis of mine and seeing a number of other people restore these online. These are quite popular sets because of the really cool deco machine age streamlined look of it. And there are a few notable design features inside. One this is one of the early sets to use an aluminized picture tube, or at least I think this version is. There were several revisions of this set. Some use an aluminized CRT, some didn't. I think this one does have it. It's also a series strung set, but unlike other series strung sets from the time, this used, I believe, some tubes that were designed specifically for it. So what do I mean by that? Other sets used off-the-shelf tubes, the 6 series and 12 series tubes, generally like a 6AU6 or a 12AU7. But this used tubes like I think it was the first set to use the 19 BG6 horizontal output tube. In other words, they used tubes with higher filament voltages, specifically designed to use in series strung TVs. Alright, enough talking. Let's get inside of this thing. It's in really, really good shape. Yeah, it's dirty, it's faded, it's got a water ring on top, but very often some of these ribs are broken out, or there's scratches or gouges, but this looks to be completely intact. The only issue I've seen so far, I think it looks a little odd, is this power cord situation back here. It's really loose, flopping around. I don't know what's going on with that. Also, the fuse that's been, well, I don't know if that, well, what's going on with that? Like I said, there were a few revisions of this. It's possible that that fuse holder was one of the design changes and they had to carve out the cabinet a little bit to accommodate it. I'm not sure. It's pretty straightforward to take these sets apart. Take out 2 Phillips head screws here, pull off the knobs, and I was pleasantly surprised to see not only all the original knobs here, but they still have the original felts on them. That is not at all typical, which means the set may not have been serviced. I think, yeah, there's a couple screws down below as well. I'm going to put down a cloth and lay the set on its side. And I can see this is a 10BP4, so this is not an aluminized version. Oh well. No matter. So the front should come off now. There she goes. Put that aside for safekeeping. Here's what it looks like. It's a rubber cushion for the glass picture tube, speaker opening, a layer of dust. Also, often these speaker grills are dented, and this one is not. In other words, I haven't made it clear already, this is in remarkably good condition. get the chassis out. I believe, yeah, there is a screw hidden down in the center of each one of these feet. Compact design. I've heard these are a bit challenging to work on. We shall see. Very dusty. All the tubes are there. Pretty old style looking tubes too. 25L6. An early use for that tube. 25-volt filament on that for series Schematic sets. Look inside here. The horizontal high voltage stuff will be. Rather large cage. Wow, serious metal there. Horizontal output tube. Maybe a damper, high voltage rectifier, flyback, doorknob cap, and a couple resistors in there that we'll talk about later. Those are filament dropper glow bar resistors. Let's get this back on. This must have seen at least some use because there should be more than one screw holding this on. There should be some along the bottom. Seems to be kind of stripped out. So here's some big filter caps, big electrolytics up on top there. Huh. Some name and a sign: Frank L. Ohm, O-E-H-M-E, 10,230 South Rhodes Avenue, Chicago 28 ILL. May have been the original owner. Oh yeah, well, it's going to be fun to work on. So, as I said, I already have a little bit of experience looking inside my wooden version of this and studying schematics and photos online, so I know it's got runs right off the AC line, voltage doubler, a couple selenium rectifiers, fusible resistor of some sort, I believe, and these large capacitors are for the power supply. These are replacements. They're not even fitted like up into the clamps like these should be. These are probably the originals. And then the circuitry's on boards similar to like you'd seen a Tektronix oscilloscope. And the tuner down here, it's like an open frame wafer type rotary switch, kind of unusual. Paper caps scattered around down in here. Not going to be too easy to work on. So where do you get started on a project like this? Well, I've got a little bit of a luxury in that I do have some spare parts that some people might not. Like I have a spare picture tube in case this one's bad. Although I'd have to talk to the owner and explain that I would be charging more for repairing this if I have to replace the picture tube. So we'll check that. I'll do a resistance check on the flyback and yoke. But I've had pretty good luck with those components, so let's assume those are okay. First thing I want to do is work on the power supply. So these electrolytics are going to go. I've already got replacements for them on hand. That's what I'd shown in that earlier video, and I teased it with, I think I had 6 electrolytics, larger valued ones. Well, that's what they replace, these big dynamite stick looking caps down here. And I want to replace the seleniums, and I'll tell you why. Yeah, they might be okay. They might be okay for a while. However, I've mentioned a number of times now, I have a version of this same chassis in a wooden cabinet. I did power that one up. Kind of started to get a picture, get a sound. I tinkered around with it, and then a big cloud of smoke came out of it. Horrifically bad smelling smoke, and filled up my apartment because the selenium rectifiers went out and went up in smoke, and that stench of burnt selenium, you won't forget it anytime soon. I don't want to experience that again, so I'll be replacing these with diodes. Alrighty, let's test that picture tube. Got my CR70 Sencor hooked up. I see a filament glow. Excellent. No heater cathode short. No G1 short. Cutoff control is kind of flaky. Same about emissions. Weak emissions. Well, we'll let this sit for a while. I've let the picture tube sit for about 15 minutes, and the emissions are coming up into the green. I've said this before, and I'll say it again. Don't immediately jump to the conclusion that your picture tube is dead or bad and start trying to rejuvenate functions. These picture tubes sometimes haven't been turned on in 50 plus years. Let them warm up for a while. And even if it doesn't get any better than this, this will still produce a watchable image for a while. It's impossible to say how long a picture tube will last. Yeah, they do give you sort of a emission life test, and ideally it would not drop when you push this button. What this does is it reduces the filament voltage by a certain percentage. So no, it's not a great sign, but if you're just going to demonstrate the set periodically, this will produce an image, I'm sure. I pulled out my Wallace Teleaid series. It covers all General Electric TV models from 47 to 51. It's kind of a convenient format to work in. So unlike Sam's, which had one set of pages for each model, or Riders, which had gigantic books that covered all manufacturers, all models for a given time period, they split up a little bit differently. Fortunately, it's fallen apart a little bit, but here is this set. This schematic covers the 800C and D. And I'm studying the schematic a little bit, and it is a little bit of a departure with the design. I think GE, like Motorola, went their own way. By that I mean RCA came out with the first real TV made in any kind of volume after World War II, and other manufacturers like Admiral kind of based their design on theirs, used the same flyback, licensed some design features, but this is a bit different. So as I mentioned earlier, series string. So there's 2 strings here. And a bit of an unusual power supply, also similar to the early Motorola sets, the transformerless sets anyways. And then some other odd features. So that fuse on the back, it's actually, I believe, replacing the thermal cutout that had been there. So they had something like a circuit breaker in these sets. If it draw too much current, this would pop open and you could push it in and reset it. Maybe whoever worked on this set couldn't find one, I don't know, but I'm pretty sure that's what that fuse holder is all about. Also kind of wish I'd studied the schematic a little bit more before I just looked at the parts list and ordered parts, because it turns out that some of these caps, like these two 150s and these 260s, are in parallel, so I could have used a single 300 there and a single 120 here. And notice there's four 150s, 150, 150, and two more there. That's what these four caps are down here, the big ones. So I could have eliminated, or I can eliminate one of these by putting a 300 in place. And I believe the two on top, on the other side, are the two 60s. So this, as I mentioned earlier, has some a little bit unusual tubes, like a 25W4 for the damper, and 25L6 for the audio output. That's that guy's early 25L6, the shoulder type. Also must have been some production changes, because the tube latch is a 25Z6, and that shows a 25. What did I say? 25W4. And if you add up all these tube filaments, they do not add up to the line voltage, so that's why they have these two resistors in here. Those are those resistors inside the high voltage box I mentioned earlier. And originally they used something called glow bar resistors. Another name for a thermistor, basically. They are probably not good anymore, or at least not within spec. And they also run very hot, I've been told. So we'll see about replacing those with capacitors or diodes or something else that will reduce the filament voltage without producing quite so much heat. As for the rest of it, 6AU6 RF amp. I don't think I've ever seen that before. And apparently it's got a two-stage RF amp. I don't think I've ever seen that before either. 12AT7 oscillator mixer. That's somewhat conventional. Usually you'd see a 6J6 or a 6AG5 in this application, not a 6AU6. Must have really liked them, because that's what all the IF tubes are as well. 6A05 detector, a 12AU7 first-second video. It's conventional. It's got DC restoration. That's a nice thing. We'll talk about that later. Vertical 12SN7. Pretty conventional. Sync clipper, more 12SN7s, horizontal sweeps. There's that 16BG6 horizontal output tube. High voltage rectifier, damper, and then audio, more another 6AU6, 6A05 ratio detector, 6XQ7 audio, and a 25L6 audio output. Alright, that's it in a nutshell. So I want to familiarize myself with this, make sure exactly which caps correspond to which ones on the schematic, and replace these guys. There's also a big one up in here. I got to figure out what that one's all about. And then those two on top. So it's my first mission, is to replace all these large electrolytics. Also free up some room down here so I can work in here. I was also surprised to see this. It looks like a dog bone resistor. I don't know if that's original or what the heck that's all about. I don't see any others in here that look like that. And then I can also, the more I look at this, the more I see it's not going to be fun to work on. It's bad enough having to dig down deep in here to get to these, but some of these up in here, because the other end of the caps are like way down in there. It's going to be a little challenging, and there's no way I'm going to remove those boards. It's way too much work to disconnect them and get them out. If I even could, these might be riveted. Oh, I see. They're metal plates riveted to these phenolic boards, and then they are screwed to the top of the chassis. So I guess you could loosen the nuts up there, and maybe these do pull down a little bit. I don't know how much slack there is on these wires. Also seem pretty stiff. I don't know how much I'm going to try flexing them. But maybe you can undo those and kind of pull the board out a little and bend it. Wow, is this thing convoluted. I just spent a good half hour just trying to figure out what the heck was what, because unfortunately none of the service info I have has a parts locator on it, so I had to kind of reverse engineer the wiring here. So I was a bit off in my assumption about which caps are which. These 50 microfarad, 450 volts. And I eventually determined that the two positive ends were connected together here. Negative end of this one was going off that away. But it turns out that it does eventually come around to this guy. So these are connected in parallel. These are these two caps. The two 60 microfarad actually had 50 in it. And the other two down there are these two guys. These two. And so there's the two selenium rectifiers. This is a flexible resistor. It is this guy's 5 ohm resistor here. Kind of an old school way of making a wire wound resistor. And that is a filter choke. On the schematic, it shows it as a speaker field coil. Some versions of the set had a speaker with a field coil. This is a permanent magnet. Speaker down here, this field coil. And one wire goes right to the junction of these two positives. So that's how I was able to figure out, oh, that is that side of it. Crazy thing is, one of the crazy things is the other side of it. That filter choke goes right back over here to a terminal strip, and there's a wire going right back way the heck over here. And that is this point. And then here's these two caps. So, what does all that mean? Well, these two I can replace with one cap. And these two I need to use two individual caps. Now, mounting them could be a little interesting. So the original mount is a metal clip with an insulating piece of material here, and bent up at a U shape, and the cap would be in here, and the ends would go out through holes in that insulating material, and the wires were just soldered on there. So no terminal strips, nothing like it here. So modern caps, it's a little hard to find the types that have a wire coming out of either end, the axial type. Far more common to find radial, where two leads come out of one end. But regardless, where the heck am I going to mount them? No terminal strips, nothing. The diameter isn't going to be right to fit in here. I could wrap some electrical tape around it or something, or squeeze these together so it would kind of fit in there. But then I would just have two leads coming out. I don't want to solder a bunch of wires to it and have it not be very secure. So I'm thinking I should remove all this stuff and mount a terminal strip or two down here. The three caps I'm going to be putting down here are all far smaller. Altogether, they'll be about the size of one of these. So definitely free up some room to work with. Likewise, I think these two guys are going to be going bye-bye. Except that one of them has a terminal strip attached to it through a screw running through here. But I think once that's cleared out, I can just mount that terminal strip down a little lower. I should have enough slack. The one reason I want to do that is I do want to see what the heck is going on in there with that wiring. It's very tight. When they put this together, I noticed, like, there's no way to get at this stuff as it is. So you got metal here, metal on top. But this is actually a sub chassis. You can undo these screws here, and this front section kind of comes off. I don't want to do that, but if one had to really get in here, like to replace a control or something, that's how they did this originally. This front came off, they probably put all the parts on here, and ran some wires through, and then attached to this, and then connected up the rest of it. This big guy here, I believe, is a vertical output transformer. I haven't identified this cap yet. And then there's just 2 on top, because there should be 2 more 150s in parallel. I want to find those guys. Those go right off the AC line and feed the voltage doubler. And yes, this is a, well, no, it's not exactly a hot chassis set, but it is one side of the AC line. It goes directly to B- in the set. But notice that 470K resistor there with the little ground symbol. That is chassis. So if you measure between the AC line or the negative on these caps and chassis, you get about 470K. So this chassis is actually floating. But the negative, or one side of the AC line is the negative B-, just sort of like ground or 0 volt potential compared to B+ anyways, and that just kind of runs all around through the set. It's a little confusing to work on. When you measure voltages, resistances, you cannot go and put the negative lead on the chassis and then measure around. Now you got to find B-, which happens to be this wire here, and also this wire over here. Perhaps they were consistent with their color coding, I'm not sure. Notice we got some red wires. This is the main B+ here. And there's also a green wire here. These black, this is sort of the 1/2 B+ bus here. Now they call it B+ and B++ and B-. So perhaps the tan wires are B-, the red are B++, and the black is B+. And I'm not going to rely on that, but it's a possibility. Some of these wires, it's a little hard to tell what color they are. Okay, I found the other 2 150 microfarads. One up top, and that is in parallel with this guy down here. So that is those 2, which I'm definitely going to replace with a single cap. And just to keep things fun, there is another one electrolytic up there. I'm not sure what that one is. There is another one up here, which looks like it's 3 sections maybe. And there's another multi-section can on top, buried down in there. In other words, this thing has a whole heck of a lot of electrolytics. I just made another breakthrough. That funky looking resistor here, that was off of the 2 50 microfarads that were in parallel, and that is going right to one section of this can up here, and it's going off over this way. I'm pretty sure if we follow the schematic. So after that filter choke, we've got B++, B+, but there's also a wire coming off of this 2 electrolytics in parallel, plus 275. It goes down and around and around and around and around, and over to the audio output transformer. And here is a resistor, 220, and there is one section of the electrolytic, 10 microfarad, square lug. I'll try to verify that that's a square symbol, but I'm pretty sure that is that funky looking resistor. Should be a 220. I seriously doubt that's the original. I mean, clearly back in the day, somebody worked on this side. I think all the electrolytics down here, at least, or at least these 4 are replacements. Possibly these 2 are original. Obviously, these are replacements, like electrical tape. The fuse holder is a replacement. I'm pretty darn sure that resistor is a replacement. I think the rest of it is original, though. All these paper caps appear to be unmolested, and I don't see any evidence of the resistors or any kind of work being done all down in here. Okay, so here is the plan. Move all the big old electrolytics, including the clips. Installed some terminal strips. Now I cannot use any of the grounded lugs on the terminal strips. Or this isn't ground really, this is sort of RF ground, but it's not circuit ground. So I mentioned a moment ago. However, upon further study of these component strips here, that metal along the back there, that is B-. I just thought I was curious that they have sort of this red coating on all the solder joints. Anyways, so I can't use one terminal on any of these strips. I have to be careful not to attach anything to it. So the one over here will be for these two caps. So I'll mount probably one from here to here and the other from here to here. I'll really only need 3 terminals because 2 of the leads attach together. Alright, so that's that. This will be for the 3-section cap up there. And this will be for the 2 caps that were here and the cap up here and the cap up here. So for those I am gonna double them up. So instead of 2 150s in parallel, I'm gonna use a single 330. So this is the main cap right here for the B+ supply for the voltage doubler. So that's that guy, and then for these two, I'm going to be using a 120 for 420 volts. So these two are going to go in here. I think I've got enough terminals. Oh, and these are a couple 150s. These will replace these 2 red caps, so yeah, a little bit smaller. So these 2 will go onto that strip. And up here, I have to look up on that. I need to replace this guy. This measures 500 something ohms. So from what I can see, body and dot, kind of the old color coding scheme. I think this is a 510 ohm resistor. Should be a 220, so it's going to get replaced. So that's got to also get in here. So I'm not sure I got quite enough lugs because I need one for each of the caps and then a common negative, and I can't use that one, so we'll see. I'm also looking at the possibility of relocating that this cap and resistor may be over here. So there's a terminal strip down in here, and that's where this goes to, or at least that 10 microfarad cap. So this goes off B+ through a resistor, 10 microfarad, over to the output transformer here. So I might be able to put that 10 microfarad cap up in here.